Hello, everyone. I was genuinely looking forward to being there with you today. However, given the prevailing geopolitical circumstances and the very uncertain travel scenario that we are in, I had to cancel my travel plans and connect with you virtually. Although this format limits the spontaneity and vibrancy of an in person exchange, I'm fortunate to still have this opportunity to share my work and perspective with you.
Over the next 15 to 20 minutes, we will explore how to align responsible AI in the probabilistic world of large language models and AI agents. These are from my learnings on what worked and what did not. I'm grateful to the wonderful organizers of 6th European Chat and Conversational AI Summit and Scottish Government for inviting me to this esteemed gathering. A brief introduction about me. My name is Shubhradeep Nandi, and I'm the Consulting Chief Data Scientist for Government of Andhra Pradesh. Andhra Pradesh, AP, is one of the most technologically forward states in India. I'm also the co-founder and chief AI researcher at Responsible AI. I'm the creator of TextLlama, a fine-tuned Llama version for GST-related tax frauds, Lamika on language modeling credit assessment, where I proved how LLMs can aid in fair credit assessment. Today, unfortunately, credit assessment is broken. This leaves many people out of the formal, cheaper credit system. Now, let's get started with the basics. So we are in the third generation of AI, but there has been three generations. So we will quickly cover them. So Gen AI, the period is from 1950 to 1970. We have seen the birth of AI, the early years when the term artificial intelligence was coined. From there, we have seen the rise of symbolic AI, although by 1970, due to massive gap between promise and delivery, we have also seen the AI funding winter. Next came the Gen 2. This is when the GPU, or I would say the hardware, became cheaper. So this period is from 1990 to roughly 2016, when we have seen IBM Deep Blue coming in. It actually showed how AI can defeat the then chess champion Garry Kasparov. From there, we have seen big data revolution. We have seen AlphaGo from DeepMind coming in and becoming a better player than the human Go player. Mind it, Go is way more complicated than chess. Well, now we are in Gen 3. In Gen 3, the key innovation was transformers. And from there, we have seen the ChatGPT movement. We have seen the DeepSeek MOE movement, multimodal and agentic AI taking precedence in the way we work. So, what really changed? Uh, the fundamental change in generation 3 of AI was the emergence of powerful transformer architecture. At its core, this architecture works probabilistically. It learns patterns in language and predicts the most likely next token in a sequence. Essentially, learning to fill in the blanks based on context. This shift from rule-based to or deterministic systems to probability-driven sequence modeling is what enabled the remarkable capabilities we see in modern large language models. So, what is this global AI shift? AI systems are moving from automation to autonomous decision making. LLM and agents now impact credit approvals, fraud investigations, welfare distribution, compliance monitoring, and many more use cases. The key reality, though, is that modern AI is probabilistic and not deterministic anymore. So let's try to double click on deterministic versus probabilistic AI. Now, if you see traditional AI, it is primarily rule based, binary outcomes, easy audit trials are possible, and it's a predictable behavior. Whereas when you come to LLM and AI agents, it is essentially confidence driven outputs. Context sensitive means every time if you change the context via the prompts or the language of the prompts change, the output changes. Emergent reasoning, we have seen frontier models developing emergent behaviors. And finally, there is a non-linear risk exposure. So the challenge here is that it's trust without certainty. Therefore, the core question, is how do we ensure fairness, accountability, and public trust when AI decisions are inherently uncertain. This requires architectural responsible AI, not post hoc governance or model explainability just as an add on. So, what we are essentially saying is ethics and explainability must be engineered into pipelines. So, what does this responsible AI architecture stack look like? This is from our experiments and our implementation. We came up with a set of suggested layers that might help to become the system more trustable. The layers include data integrity and provenance, probabilistic model governance, explainable reasoning engines, agent decision orchestration, human in the loop controls, continuous audit and monitoring. So, with this, we have seen that trust becomes a system property, not a report output. Hereafter, let's dive into a case study. So, we are talking about credit risk assessment. Now, the challenge that we have seen is a binary credit level hides uncertainty. There are observed risk bias across demographic segments. We have seen that the most common biases include PIN code, religion, job, age related exclusions. The bigger challenge is that wealth distribution remains unequal, and unfortunately, many sections remain deprived of formal cheaper credit. We came up with a solution, and this solution included eligibility probability, confidence intervals, key contributing factors, and fairness diagnostics. In the next slide, I'm going to showcase you how our output looks like. What it helped, the impact was this: it gave better underwriting transparency, regulator ready decision trials, human accountability over AI outcome. Here is an example output. So credit decision interface included a score, which is a probability of repayment, a confidence band that shows that plus minus this would be the value. We ensured reproducibility is there. So once and we had reproducibility equal to US, we say the result is trustable. Next, feature attribution. So what attributed to the outcome? So we enlisted the features. It included the cash flow stability, debt servicing history. We also observed that both in the way the data was trained and its behavior, there are biases. An example bias is like this towards gender, small and medium businesses between the age X and Y. So we essentially started also showcasing the biases. Now this helped the human underwriter to essentially make a better decision, and it's not just a blind automation. The second case study is about welfare benefit transfer. Now, welfare benefit transfer is a key methodology in which government distributes wealth to its subjects to ensure that the underprivileged gets benefit. Now, the challenge here is that public sector requires explainability for citizens. So essentially, if we give a benefit to a particular family and it is not given to another family or a household, there has to be clear explainable reasons. Algorithmic opacity essentially reduces social trust. Now, if your algorithm is unable to explain it, the social trust is reduced by multiple folds. Now, to this, we came up with again a solution which essentially generates eligibility recommendations, produces human readable rationale for why a household was given benefit and why a household was not given. Visual clarity, which includes income thresholds, household dependency score, regional policy adjustments. So essentially, what we are trying to showcase here is more and more clarity, transparency, and accountability. So this enables citizen level transparency. The third case study that I'm going to cover today is about fraud detection and monitoring. Now, black box alerts do not lead to evidence-based investigation. Very difficult thing. High false positives lead to higher harassment. Imagine somebody is innocent and an investigation is put on. That's an harassment. The third thing is the head of the department uh, also has fatigues, which essentially leads to the death of the proof of concept. So just simplify this is if your solution is not trusted, explainable, transparent for the head of the department who is trying to implement it, then it remains just as a POC. It never goes to production. So for this, we built a hybrid solution, unsupervised ML for suspicious transaction clusters, then deep human readable reasoning trains, network anomaly detects anomaly signals, behavioral deviations, temporal transaction spikes, and the complete chain of thought scribbled. Now, this helped in supporting evidence-based investigation. We focused on precision negative management, leading to low harassment and low leakages. How we embedded responsible AI. Now we are at the most important slide. From all our experiments, implementation, and success, we have built a recipe. Our recipe is a fine-tuned mix of standard, custom, and out-of-box solutions. Let me go point by point. So the key engineering components include confidence calibration layers. This is a custom solution, which includes risk likelihood, reproducibility, validation thresholds. Next, we have agent security threat risk assessment layer. Agents are going to provide you the maximum automation. So here we have an out-of-box solution developed in-house at Responsible AI. This you can just plug in and it helps you to get a state of how safe and secure are your agents. Bias drift monitoring. You don't want your agents getting drifted from their original state and objective. That's where we have again an out-of-box solution. This is called Athena. It is again built in-house by Responsible AI. Next, we have prompt breakthrough. Now, prompt breakthrough essentially protects your agent or AI solution from jailbreaks and other harm development. So this is also an out-of-box solution that has been built inside Responsible AI called Aris. All of the solution you can get access to, you can connect with us and get access to. After this, we realized that it has to have a decision tree storage with explainability. So that is something we provide with human readable reasoning, stack trace, and observability. This is again a custom solution. We also ensure that human is always in control of the action, so that if something goes wrong, human can override and take the control in her or his hands. So for this, we have two-stage decision architecture is a standard and escalation ladder. So going ahead, we are now going to see the key takeaways. So probabilistic AI requires architectural responsibility. Explainability must be operational. Confidence-aware decisions improves trust and regulation readiness. AI systems, including agents or agentic AI, must remain human-centric by design. The systems are going to stay, so it's better to embrace, experiment, and stay on top of it because that will give you the competitive edge. Finally, here is the cheat code. Well, we have identified 7 principles. Now, whenever you are trying to design AI solution, and that also with the new age modern AI, then definitely you need these 7 principles baked in. So, what are the 7 principles? Let me try to simplify a bit. So, let's say if you are building an agentic solution or a simple AI solution based on LLMs, right? The first thing is it will have an objective. The objective is to predict something, and you need to do that. But simply prediction won't solve the purpose. You need to have explainability. So, there should be some steps. which shows why this particular decision was taken finally as an outcome. Well, explainability talks about the steps, but then you cannot leave it there. You have to go into justification. So that's the third step, right? You need to justify why have your solution given this particular prediction. You cannot just tell that the frontier model has chosen this outcome, so this is my solution. No, you have to justify it. After this, your system should have options that it can be audited. It has to have all the four things before baked in, plugged in, and people should see the essence of trust in your outcomes. Now, let's say you have drifts. Your solution is essentially been broken very easily. Jailbreaks are very common. Then nobody would be trusting it. So you need to have trust baked in. Finally, reproducible. Again, very important. Why? So your underlying frontier model or whichever AI system that you are using to power your outcome might have a probabilistic nature, which means that the solutions would, with a little bit of change in the prompts, little bit of change in the context, the output might vary. And here I'm not saying that the use case is changing. I mean, the use case is same, the data is same, but the way you have framed the prompt, it might lead to a different outcome. You cannot risk that. Every time for a specific set of information, your output in a regulated industry has to be reproducible. And this is the final and the most important principle. So once you bake in these 7 things within your solution, be it AI solution or agentic solution, you are sorted. Okay, so here comes the final side. First of all, thank you so much for patiently listening to me. My coordinates. You can email me, you can LinkedIn, do a LinkedIn connect with me. But here it is. What I have told you until now in this last 15 to 20 minutes was essentially pointers. There was no way I could go deeper, but let's say you have a use case and all these pointers which I have said make sense for you, then definitely reach out on my email or my LinkedIn. I'm happy to brainstorm with you and help you in your journey. If you would like to go into to know more about responsible AI, then here you have the website. We have recently started with a video blog called State of AI Trust. Eminent people globally from the industry are coming over to our video blog and talking about how, what, when things are about AI, the current state of AI. Finally, every week we publish a blog where we put across some of our work that we have concluded. Very recently, we have done some work with one of the foundations. We have been able to drift an enterprise agent, and we have found some critical issues or security gaps in OpenFlow. So we have put it across in our blogs. Please do pay a visit. I again thank the organizers for giving me this opportunity to share my experience. And to all of you whom I could not meet personally, I thank you for listening to me. Have a wonderful rest of the day and a wonderful conference. Thank you.